First, let's talk about special relativity. Why would an expanding universe maybe violate special relativity? Well, if you have a universe that's expanding, at a certain point, it reaches a certain size. If it's expanding at a certain rate, the increase of the volume could be larger than the speed of light in certain places. But what we can see when we analyze the equations for special relativity is that these restrictions on the speed of light, they apply to the transfer of information or the transfer from an object of a certain location to another. And they don't actually apply to the space itself. So while it's true that an object can never travel faster than the speed of light in going from some point in the universe to another point in the universe itself is not necessarily confined to this restriction. And that has to do with the geometry intrinsic to general relativity. First of all, general relativity does not have the same restrictions for the speed of light necessarily. It's a little known fact that the speed of light restriction applies to special relativity in Minkowski's space. It's a geometrical relationship. As far as we know, space throughout is generally Minkowski. Okay, it's mostly flat, and there's a few little areas like in black holes where it's extremely curved. And this is why we don't have a full unified theory yet, because we can't necessarily address all of the dynamical situations going on quantum mechanically in these regions, like these singularities. This is the kind of stuff that Hawking and Penrose worked on trying to figure out, but the work is ongoing. But as far as why the expansion and inflation doesn't violate special relativity, that one has to do with the fact that space itself is not bound to the speed of light restriction. It's objects moving within that space.